Hi, these are the answers to page 146, and we're working on implicit differentiation. So when you do the derivative of x squared, you're doing it with respect to x, so the derivative will still be 2x, just like we're used to. But when we do the derivative of y, you got to think of it like a chain rule. Y is inside of the squared. So you do derivative of the squared, bring the 2 down, change it to a 1, right, just like you normally would. But then you got to multiply by the derivative of y, which we've been calling dy dx. And then the derivative of 16 is just 0. Okay. Now if you subtract 2x, you're going to get negative 2y dy dx equals negative 2x. And then if we divide by negative 2y, we get dy dx equal to negative 2x divided by negative 2y, or just x over y. And that's our derivative. Right. Similar idea here, derivative of x cubed would be 3x squared. Derivative of 3y of y cubed would be 3y squared for the outer function times derivative of the y, which is dy dx, equals derivative of 8, which is 0. If I subtract, I get 3y squared dy dx equal to negative 3x squared. And then if I divide, I get dy dx equal to negative 3x squared over 3y squared, or a negative x squared over y squared. When we get to number 5, I take the derivative of x cubed, that's 3x squared. I got to think of this as a product rule. I'm going to think of it as negative x times y. So the derivative of negative x would be negative 1 times y as is, plus negative x. So actually I'll write that as minus x. Okay. So we're going to write it as minus x times the derivative of y, which is dy dx. Okay. Plus the derivative of y squared, which is 2y times dy dx, equals derivative of 4, which is 0. Okay. Now what we're going to do is we're going to move things that don't have dy dx over to this side, and we'll keep these sides. And when we keep them, what we'll do is we'll just factor that dy dx out. So the terms that have dy dx is negative x and this plus 2y. So I've factored the dy dx off of those. And then we're also going to bring these over. So if you subtract 3x squared, and if you add y, okay, you get that. And now I can divide by this term here. And so we'll get the stuff that was over on this side, negative 3x squared plus y, divided by this negative x plus 2y. Right? And then that's our answer for that. For number 10, we've got a product rule. So I'm going to take the derivative of 2 sine x, that's 2 cosine x, leave the cosine y alone, okay, plus, now leave the 2 sine x alone, times the derivative of cosine y. So the derivative, we're going to do the outer one first. Derivative of cosine is a negative sine. And then we'll leave y alone, times the derivative of the inside, which is dy dx. And then derivative of 1 is 0. Okay. So now I can subtract this over, and when I do it, I'm also going to bring this negative out here. So I've got a negative 2 sine x sine y dy dx equals, and I'll subtract this, a negative 2 cosine x cosine y. Right? And then if we divide by that, dy dx equals negative 2 this, divided by negative 2 that. So the negative 2's will cancel. We'll get cosine x cosine y over sine x sine y. And if you wanted to do cotangent x cotangent y, that would be fine too. Okay. But that's our derivative. For number 24, we're doing the derivative at a point. So we'll do the first pass through implicitly. So if I bring that 3 down, it's 3, leave the inside alone, squared. So that's the derivative of the outside, times the derivative of the inside, which is 1 plus dy dx, equals 3x squared plus the derivative of this, which is 3y squared times dy dx. Okay. So that's our thing. Now we can, if we want, try to work all this out and get dy dx by itself and then plug this point in, but there's no need for that. I think the easier thing to do is just put this point in right now. So we're going to have 3 times negative 1 plus 1, which is 0 squared, times 1 plus dy dx, equals 3 times 1 squared, which is, or negative 1 squared, which is 3, plus 3 times 1 squared, 3 dy dx. Okay, now this is nice because this then zeroes out. So you would have done all this crazy work over here that you didn't need to, because this actually goes to 0. And then I can subtract 3 and divide by 3, and we end up with a slope of negative 1. So that's our answer for that. And for 32, same idea. I can do a derivative, 3x squared plus 3y squared times dy dx. When we get here, this is going to be a product rule. So a derivative of negative 6x is negative 6, leave y alone. Plus, now negative 6x left alone times derivative of y, okay, equals derivative of 0, which is 0. All right, now we can put 4/3 in. 4/3 squared is 16/9 times 3 will give us 16/3, plus 3 times y squared, so 8/3 is going to be 64/9 times 3 will give us 64/3 dy dx, minus 6 times y, so that's going to be 48/3, minus 6 times x, that's going to be 24/3 dy dx. Now I realize some of these don't have to be written in thirds, but I think it's going to help us do the next part, okay? Because what we're going to do is now we're going to add 48/3 and then subtract 16/3 and bring those two terms over to here. When we do that, that's going to give us 32/3 on this side. And then I'm going to go ahead and go 64/3 minus 24/3, which is 40/3 dy dx. All right, we're almost there. Now the last thing we're going to do is multiply by 3/40 to get that canceled. And dy dx is equal to, the 3's cancel, 32/40, which is the same as 4/5 or 0.8. Okay. So look at your initial pass. Did you do that part right? Then plugging it in, yeah, is a little bit of a nuisance, but if you stay, kind of calm, you should be okay. All right, same idea on 34. We're going to do our derivative. So this is a little chain rule. Bring the 2 down, leave the inside alone to the first power, times the derivative of the inside, which is 1. So that just stays like that. For this other one, we'll bring the 2 down, bring it to the first power, times the derivative of the inside, which will be dy dx, equals derivative of 20, which is 0. Okay. Now again, let's put 3 and 4 in here just right away. So if I put 3 in for x, I'm going to get 2 times 4, which is 8. And then if I put 4 in here, I'm going to get 2 times 2, which is 4. And then if I subtract 8 and then divide by 4, I'm going to get a derivative of negative 2. Okay. And now 45 wants us to find the second derivative. So we're going to take the first derivative of these. And if I subtract 2x and divide by 2y, I'm going to get dy dx equal to a negative x over y. So that's my first derivative. Now I'm going to do the derivative of that. So my second derivative, this will be a quotient rule. It'll be bottom times derivative of the top, which will be negative 1, okay, minus the top, negative x. So that negative and this negative will become positive, times derivative of the bottom, which is dy dx, all over bottom squared. Okay, so that's good, but in order to get full credit, when you see dy dx, we got to sub in what dy dx was equal to. So we're going to get negative y plus x times negative x over y, that's dy dx, over y squared. And there's our second derivative. So it's that, do the first derivative, then make sure you do quotient rule for the second derivative, and then sub back in for that. Similar story over here for 50. I do the first derivative, 2y times dy dx equals derivative of that, which is 4. So I get dy dx equal to 4 divided by 2y. So that's going to be 2 divided by y, or 2y to the negative 1. Okay, that's my derivative. Now my second derivative will be, bring the negative 1 down, negative 2y to the negative 2 times dy dx. And that's going to be negative 2y squared times 2y to the negative 1. And if you do some combining there, that's going to give you negative 4y to the negative 3. But either one of those would be fine. So those are the answers to the book work.